For the second proof on this page, notice that we don't have this written in our nice if-then form, which means that we don't automatically have identified the hypothesis and conclusion of the statement. So it's worthwhile, and this is why we spent some time on this in section 1.5, but it's worthwhile to rewrite this as an equivalent statement that is of the form, that is out of the if-then form. So in this case, this statement could be written if A and B are odd, then A plus B is even. So take a second to make sure you agree that that really is stating the same thing. And notice how it has a very similar structure to the sentence before, where we have an hypothesis about a number that we've already decided to call n, and then our conclusion is about some arithmetic that's being done to n. So it'll actually have a very similar feel to it. So here's what the proof looks like. Again, we're following this sort of 4 points model. I won't say 4 sentence because especially the second and third points can be quite complicated in some proofs, but sort of 4 phases to a proof. So proof, I'll write down where we're starting it. Let A and B be odd integers. So again, we're saying, give me an example satisfying the hypothesis. In this case, the hypothesis mentions 2 things, so an example satisfying the hypothesis will involve both an A and a B. This means, so again, phase 2, we're explaining what we know about the example based on the fact that it satisfies the hypothesis. So that means that my A is twice something plus 1, and also my B is twice something plus 1. Now there's an interesting point here where I don't want to use the same letter. The name of the letter is sort of irrelevant. I want to say twice something, and I have to give it a letter name so I can refer back to the something. But if I use the same letter name in both places, I would basically be implying that A and B are the same number, right? They can't both be true. So I can't use the same letter in 2 different places to stand for potentially 2 different values. If I use K again, it's got to mean that same K. If I use L again, it's got to mean that same L. So if I need different letters, I'll just use different letters. And it is relevant that the K and L here are whole numbers. That's an important aspect to the definition of odd. For some, K and L, and again, I'll just use the shorthand, this little e means is an element of, or you can just read it as in, I-N, in the set of integers. So that's my second phase. I've told you everything I know about the A and the B that you may have picked as the reader. So now I have some transition word that suggests that I am now turning my attention to the conclusion. The conclusion is about A plus B, so I should start off with A plus B and write down what I do know about it. So A plus B, well, I know that A is this guy, and I know that B is this guy. So I can simplify that. That's 2K plus 2L plus 2. Now I might have to look back at the conclusion to remind myself what it is exactly I was trying to say about A plus B. You can see I need to show that A plus B is even. And remember that being even just means is a multiple of 2. So is this a multiple of 2? Well, if it is, I should be able to write it as 2 times something. And in this case, that will feel more like algebra, like I'm just factoring out. But yes, I can write this as 2 times K plus L plus 1. And, and so that really is 2 times a whole number. Again, the only reason I know that the stuff in parentheses is a whole number is because I know that K and L are whole numbers. And I'm using, again, the fact that when you add whole numbers, the result is a whole number. So since K plus L plus 1 is definitely an integer, then my this previous sentence shows that A plus B is even. Okay, so that's the way our proofs go. Let me say a quick word about what we call tracing a proof, because there are some exercises that you'll see in D2L that are related to this. Tracing through a proof is a handy way to just read through it, make sure you understand what all the words are, and it's essentially just responding to the proof the way that we responded to the instructions all the way back here. Oops, all the way back. Where was that? Too far. All the way back here in this first example. When we were doing our proofs as letters, the author would say to do something and the reader would actually do it, right? Actually give a number. And so that's all we mean by tracing a proof, is going back to that model. So in this case, if I'm really tracing this through, it's handy to perhaps number the sentences. So the first sentence says, let odd integer x and even integer y be given. And then over here, say over here maybe, in my trace, I'll put the number 1 and I'll say, I chose x equals 13 and y equal 4. And then sentence 2 says that that the x is really twice something plus 1, and so in line 2, my 13 is twice 6 plus 1, and so that means my capital A is 6 for that choice. And the third sentence, I mean, this is still in the second phase of the proof, right? We're just saying what we know. But the third sentence is the definition of even, y is equal to 2a. So the y here, 4, is 2 times 2, and so that means the a is 2. So line 3, the a would be 2. And this is actually a bad proof. It's an example of what not to do. Notice I've used the same letter A, and A can't really be 6 and 2 at the same time, so there's something bad that's going to happen in this proof because of that. But it's not really relevant whether it's a good proof or a bad proof. Tracing through it really just means making choices for each of the sentences. So when the sentence says to do something, you act like the reader and really do it. And there are a couple of exercises in D2L that ask you to look at a proof and then trace through it with some certain choices. So I think that's a fairly straightforward thing to do, and it's really just intended to get you to sort of get used to reading proofs. So before next time, what would be good is to try to prove a few simple things. These three things are all written already in if-then form, and I think you'll find that that their proofs are very similar to the proofs that we just did as examples. We obviously will be getting to some more interesting proofs, some more complicated proofs. In particular, we'll try to prove all of the things on here that we marked with a T. We proved this one already, so that's one down. But we still have several other things to prove that that right now are beyond our beyond the ability that we've built in. So start off, practice some easy proofs, and then on Monday we'll get back to trying some more difficult ones.